I think some speakers, some participants, mic is not muted here. So before we start here, so let us remind a few of the general guidelines. So during the presentation here, all are requested to kindly unmute here. If you have to ask some things, then you can ask here, or you can type it in the chat box here to ask a question from the speakers here. So meanwhile, it is recommended here, don't disturb here. So okay, let's start. So very warm good morning to the respected eminent speaker, Dr. Sudhakar Pandey, with us here as faculty members from the different institutions across the India, research scholars, and the students here. On behalf of Triple IT and our family here, I, Dr. C. Vishal Tripathi, faculty in EC department, as well as the FTP coordinator, I welcome you all on the third day, seventh session of this technical session here. In this FDP, which is sponsored by the AICT Training and Learning Atal Academy here. So before we move on here for the third day session 7, or it is the third day session first here. First, I would like to give a brief throughout about the bio of the speakers of this session here. So sir has already joined here. He is with us. So before we move on here, I would like to say a few of the key outlines related to the sir's research profile as well as bio profile here. So Dr. Sudhakar Pandey is an associate professor in National Institute of Technology, Raipur here. Yeah, he is working in the NIT Raipur here for more than 12 years and 4 months here. So at present, he is associate professor from June 2018 onwards here, and prior to that, he was associated with NIT Raipur as assistant professor from July 2008 to the June 2018. And for short durations, he was associated with the University of Allahabad as associate professor from August 2018 to December 2018. And before that, he was a lecturer in Institute of Engineering and Rural Technology, Allahabad here during the 2005 to 2008 here. Sir has completed PhD, ME, and BE here. Sir's present area of interest or research interest includes computer organizations, computer network, cellular and mobile computing, distributed computing, computer-based numerical and statistical techniques, principle of programming languages here. Set presents her as regional coordinator of RCI NIT Raipur for Unnat Bharat Abhiyan. So sir is also handling one research project here on the topic development of framework for web-based intelligent dictionary for learning Chhattisgarh languages here, funded by Chhattisgarh Council of Science and Technology. This is for the 2 years duration here. Sir is very active with the research domain here. You can see from this research interest or the research profiles here. So at present, sir has already supervised 5 PhD students and 7 students PhD is ongoing under his supervision. So till date, sir has published more than 26 papers in highly reputed journals here. So all the reputed publications like IEEE, elsewhere, and others, Wiley and others, or everywhere such publications is present here. So for the detail, you can see the profile on the Google Scholars as well as this as personal NIT Raipur profile here. So meanwhile, sir has published, I think, more than 40 papers here in the conferences. Sir is active members or is life member of Computer Society of India. He is associate members in the Institution of Engineering India here. With this brief bio of the sir here, now I'd like to request to the sir here, please take over the session here. So, sir, please.
Thank you, Dr. Vishal, C. Vishal, and
Yes, sir.
thanks to feel me proud that I am a researcher and academician. Very good morning to Dr. C. Vishal and the participants. definitely it's a good opportunity for me to spend some time with you uh, through this adult academic program, and definitely we also IIT Raipur and Department of Information Technology are also doing uh, different programs in the same platform. So since this topic has been assigned to me from your side, so I started. So the topic is artificial intelligence and Internet of Things, a new age of intelligent things. Uh, because as I know, many faculty members are here as a participants or maybe researchers. So whenever we are in academic field and in technical education, higher education, we have different responsibilities. The first one is teaching and learning, as well as research also. So from very long time, I am in wireless communication system, and what we feel that this is the area which has been changed very rapidly in from last 10 to 15 years. Because when landline was there, when mobile came there, we know very well and well aware. So what I feel, since I'm supervising some PhD students as well as I'm doctoral guidance committee member of different students of the same department or different department, what I feel that they don't understand the difference between wireless sensor network, Internet of Things, and a smart city or a smart environment concept. So sometime I hear them and they started to explain the WSN, wireless sensor networks, but actually they given the title of Internet of Things. So the role of wireless sensor network is used in Internet of Things, but both are different. We use IoT in smart systems, but both are different. So WSN is a subset of Internet of Things. Internet of Things is a subset of smart cities. So since faculty members are here, they supervise PhD candidates, or you are doing PhD. So you must know the difference. I explain, I will try to share some knowledge about Internet of Things as well as artificial intelligence, because uh, this is the time when a number of tools in form of artificial intelligence or machine learning, deep learning, optimization techniques are available. Whenever we do any research, we have a target to learn the entire area and try to improve it. So for we do a regressive literature survey, and where which surveys we get understand or get some interest, we go in depth and suppose and propose some modifications over there. But before 5 year back or 10 year backs, uh, whenever we propose any routing algorithm, so we give some new concepts, new constraints, new parameters for the routing algorithm, calculate the complexity, and if it is better, we do it. Now we have tool of AIs. or optimization techniques. So we choose the parameters for objective functions, give that parameters to a ready-made optimization algorithm or AI tool, and it gives you the result. So that is why Internet Internet of Things is a technology which we are partly using, or we will be in more use in future. So we have to understand it. Uh, and as a technocrat, we have to discriminate what is the difference between another technologies, and as a researcher, we what tools we have. And since we are whenever we uh, start to learn or get interacted with any network system, definitely our mind wants that OSI reference model, TCP/IP reference model, etc. etc. Or whenever we talk about the architecture, so we started to do the analogy in our mind with the existing architectures we have, either data communication networks or wireless communication networks. So this is the outline of my today's talk. So first, we will understand what is Internet of Things, how it is different from other technologies, what is the need of Internet of Things. Because whenever we got any new technology in our life, this is a very obvious question. Why? Because whenever a technology comes, definitely that technology should have some flaws, some risks, some complications also. So, for example, when electricity came, definitely it was quite dangerous. Or when uh, nuclear electric plants, electricity generation plants were proposed, definitely we oppose it. Or first time we went to railway station and for a reservation ticket, the clerk which was inside the counter taking much time than the manual reservation. So always we feel what is the need of this, but now we are feeling yes, that was required. So we have to understand what is the need of Internet of Things. Then I will discuss the features, because for any system or any technology, we should identify the features what we are expecting. Architecture again. Architecture, yes, we should have a robust architecture, established architecture, and if it is not established by the experience and uses, we may establish it. Protocols, uh, definitely, we already aware about the data communication network, wireless communication networks. So we expect protocols at each layer. So I will try to explain some layers and what protocols we are using in IoT, what industry and reputed companies are providing the protocols and tools. Then issues and challenges I will discuss. Then how we can use artificial intelligence in IoT. Then what are the tools which are used in IoT? Still they are using, and AI solution to IoT issues and challenges. So there is a topic issues and challenges in IoT. Another topic is AI solutions to IoT and issues and challenges. Uh, these are two topics which we generally uh, seeing more interest, or we are always eager to hear it, because these are the areas from where we get some seat to do the work or to assign the work to our PhD students. So, what is Internet of Things? One more word has been came, that is Internet of Everything, which is in existence. Uh, but this word is one step ahead. So, Internet of Things was that word was firstly introduced by Kevin Aston in his presentation of Procter and Gamble in 1999. He is a co-founder of MIT's Auto IT Lab, and he quote a word: "We need to empower computers with their own means to gathering information, so they can see, hear, and smell the world for themselves in all its random beauty." So, the above Kevin quote would have given you an idea about the ideologies behind the development of Internet. We have the systems, we have the computers, we have clouds, we have networks, and definitely these are using for us as well as the environment. But the drawback is this: whatever we are providing to the system receives only that data, that information, that scenarios and situations. Uh, we are trying, our system are trying from a long time that we will make computer system as much as smart, that it acts as a human body. Now we are thinking to make it smart, that it sense the environment, it smell the environment, hear the environment, and take the decisions. So this is the responsibilities of Internet of Things. For example, there is a figure having one car, means a automobile system, one camera, video camera, means surveillance system, some electrical equipments, and some electronic equipments having computational power, having communication power. So we are trying to connect all such devices through internet, and not only connect, to receive the messages and to give the control. So Internet of Things is a network of devices which can see, which can sense, accumulate, and transfer data. Sense means the devices which are connected, they should be capable to sense the environment, accumulate. Once they sense the environment, they will send the sensed data to the cloud or a centralized system or a distributed system, wherever the data will be treated, and transfer data over the internet without any human intervention. So a person over here, maybe he has the authority of these equipments, the authority of the internet or communication channel, but he has no role now. The things which are connected with the internet are capable to sense the data, create the data, send the data, receive the control, and accordingly act. So the evaluation of internet, to understand it what it is. So it will interesting to have a look at the evolution of IoT in these four topics, in this four subheadings: pre-internet, dawn of internet, internet of people, and internet of things. So before internet, we were communicating. We were communicating to communication channels, have trunk lines, have landline phones, and SMS via mobile phones or via pager system. Pager system was a technology which had a very short age, which came in between mobile phones and landline phones, and having the capability to send the message only. And it was a unidirectional communication. So to send any message to a pager user, you have to call at a particular number. They generated a message and send it to them. So in pre-internet era, most of the human-to-human communication was through fixed and mobile telephony only. Mobile and in case of mobile, we use SMS. Dawn of internet. So with the origin of internet, the world changed at once. There could be continents apart and still share vital information at just the click of a button. So this is the period when we had some limited websites having limited access and to get the information. We had Yahoo, we had IndiaTimes.com, RedditMail.com, Hotmail.com. So we are capable to send the messages, mails. We are capable to share the attachment, uh, some attached files also, but it was too limited. And I remember that we started to spend the time on internet, on system once we get the internet. Before came out the internet, we were very less interest on computer. What do you think? This is a system, a bigger size calculator, having more capability of computation, but mm, we don't have any interest because of limited information. Whatever information we have stored in our system, either in the form of movie, music, files, softwares. But now, when we get the internet, definitely we started to spend the time on the system. Then the same internet become internet of people. Uh, about around 2000, we have some interesting websites, blogging, social media began to explode the popularity. Sites like MySpace, LinkedIn, Facebook, it came after or in early 2000. YouTube came, and now we can spend how how much we want to spend on the internet because these are the tools and sites we have. So, evolution of IoT. So, nearly all the data available on the internet today was first captured and created by human beings. We have, it is possible that we get the data from some device, but this has been given to the our system or net by human being. So human intervention is still over there. The problem is people have limited time, attention, and accuracy, which means they are not very good at capturing data about things of the real world. So if we had computers that knew everything, there was to know about things using data they gathered without any help from us. We need to create a system where we people need not to enter the data, people need not to intervene the data. It directly sensed and go to the system. So we be able to track and count everything and greatly reduced waste, loss, and cost. and this is what gave birth of internet. So reduce waste, loss, and cost, because nowadays uh, the most expensive item is human being or the salary of a hired employee. So to reduce the number of employees, to reduce the loss, and definitely cost will be reduced. So this is an example of Internet of Things. Uh, the first one is the refrigerator example. We are using refrigerators from very long time, but it is not exactly Internet of Things. What it does, it get the temperature inside the system, and accordingly it either on or off. And there is some minor calculation that if you have set temperature on 5 degree, it, it does the cooling up to 4 degree, and whenever it came on 6 degree, it is start compressor starts. The same thing is on air conditioner. The difference is the AC sense the temperature within itself or inside temperature, and air condition sense the temperature the outside the air condition means the temperature of the room. So, but there is some activity performed between these actions. So, interact, contribute, and collaborate. And there are different components over there, and uh, these components are interact themselves, contribute, and collaboratively take the action. So the another example of Internet of Things is your mobile phone. Your mobile phone has a GPS tracking system. Your mobile phone has a gyroscope, which tells you the directions. Have an adaptive brightness, which uh, change the brightness of your phone whenever you need. Whenever you are in sunlight, the brightness increase. Whenever you are in dark area, it reduces. Voice detection system, it detects your voice and accordingly give you the rights to access the phone. Face detection, I think all of you have a face detection system on your phone, whether you are using or not, but most of the phones are there. Now, uh, you know how these different components interact, contribute, and collaborate, because this event is organized by Triple IT New Raipur, and whenever I visited New Raipur, uh, I always use GPS system, and it gives me the directions. So this is one application of GPS tracking system. Now, the need, because as I told, whenever any technology came, we will have a question that what is the need of this technology. So the things in IoT can be any device with any kind of built-in sensors with the ability to collect, transfer data over a network, which helps other devices to take decision without manual intervention. I have 10 equipments, and the functioning of the equipments depends upon the condition of second equipment. Second equipments should capable to communicate each other via net or via any other thing. As in case of refrigerator, there is a sensor which senses the temperature. On the basis of that temperature, the compressor act or react. IoT is trying to expand this interdependence of human to interact, contribute, and collaborate to things. Apart from human body, the other things should be collaborate, contribute, and interact without without our intervention. So I know this sounds a bit complicated. Let's understand with an example. So IoT continuously monitoring your health. We are facing a pandemic period right now, and the number increased, already increased a lot, is still increasing, and not only in our country, in the entire world, this is a challenge to accommodate all the COVID patients in the hospital. So the government decided to take the treatment from your home, and definitely not exactly using IoT system. They are providing you some numbers by which on that number you may call, you may message using your WhatsApp or etc. and get the uh, advices from the concerned doctor or the concerned health employee. In case of IoT system, we may uh, visualize this type of concept where the patient is at his home having different monitoring systems attached in his body, and if any irregular condition is monitored by different attached equipments, either blood pressure related or pulse or oximeter, because in case of COVID, the oxygen level must be monitored continuously. So, in any irregular condition is monitored, the hospital should be notified. But right now we have the facility to call the doctor. IoT will remove the human body to make the call. The equipments which are attached with your body, and uh, in case of any irregular situation, the system automatically intimate to hospital to take the necessary actions. Once the hospital get the message from your home or from the any equipment attached to your body, it immediately send the ambulance at patient's location with proper instructions, and on same time, since the entire system is automated, uh, the other part of the hospital regarding prescriptions, medicines, or operation theater, they will be alert, and these units will be ready before ambulance arrive to the hospital. So this is basically a full automated kind of system, uh, except giving the treatment. The most of the activity has been done by the units or things, and you may say this is a smart hospital system, and this smart hospital system will be a part of smart city. So the sensing part was the wireless sensor network. The communication part is another thing, and to take the decisions, give the messages to different units is a part of AI, because on the basis of data received from different units, the system should take some decision. It should alert different modules of the hospital, either the transportation related ambulance or doctors or for medicines or So this was the one example only, and we may go through what will be the benefits of IoT. So this is resulting in improved accuracy, efficiency, and economic benefit with reduced human intervention. Since there is no human intervention and there is no delay, since all the system will be automated, so there is no delay. So these are the benefits we may experience: accuracy, efficiency, and economic. So the major benefits of the IoT are efficient resource utilization. IoT will not generate the resource, but whatever resource we have using Internet of Things, the resources may be utilized in best way. Reduced waste. The waste generated in communication, the waste of time, that will be reduced. Improve security, because only concerned units will be informed. No other unit will get the status or information related to any patient or related to any other module. Minimize human effort, save time definitely, because the communication and actions will be taken automatically. There is no human intervention. So definitely, if it is automatically, so how much time it will take to compute and to interpret the messages and to generate the message, only that time it will be taken. Otherwise, it will save the message and to alert in advance the other units, the related units which have to do perform some treatment to the patient. If that units will be ready in advance, definitely it will save the time. Technical optimization, yes, and development of AI through IoT, because whatever data the centralized system or hospital administration unit received, it should apply. It has to take the decision on what unit. Suppose there is a cardiac related issue, so it is quite possible that the patient should take some test. So it should go to pathology. It should require some medicines. So what units will be activated? What decision will be taken by administration? That part may be performed by artificial intelligence. And since the main platform will be IoT, so it will be through IoT. So it compasses technologies such as smart grid, smart home, intelligent transportation system, and finally smart cities. Uh, I have some other examples on next slides. So the smart grid I will explain. Smart home also I have, and intelligent transportation systems. So features of Internet of Things. So IoT lets us achieve the true potential of technology using and must have these features. The first one is connect, another is analyze, and third one is integrate. So in case of connect, it should connect various things of to the Internet of Things platform. It should analyze the data collected and use it to build business intelligence. Sometimes it uses BI. So analyze the data collected and use it to business intelligence. Then integrate various models to improve user experience, because there would be more than one model, and all the models should be integrated. So it should provide proper connectivity. it should have capability to analyze the data and build business intelligence, and accordingly it should integrate different modules. So to achieve these connect, analyze, and integrate, we should have a device virtualization. Means it should create a virtual version of smart things or virtual version of devices. We will going to connect different devices, and the user should have a feel that it will have all the devices which are virtually attached and available for them. High speed message amongst the devices, and these should be reliable, secure, and bidirectional communication. And the communication should be in between the devices as well as the cloud. So the first one is device virtualization, another is high speed messaging, the third one is endpoint management. So in endpoint management, it should manage device endpoint identity, metadata, and life cycle state of all devices. So all devices should be managed and properly identified, connected, having authority, and metadata related. Then stream processing. So real-time analysis of incoming data streams with event aggregation, filtering, and correlation. Suppose I am monitoring a ground, and uh, my monitoring system is related various things. Maybe temperature, maybe humidity, maybe number of uh, number of human beings present in that ground, and uh, what light system, etc. And I have deployed 5,000 sensors over there to sense and to monitor these things. It is quite possible that many sensors sense the same area and produces the same data for produces the same data and sending the central system. So the streaming of data among all these sensors or all these monitoring systems should be aggregated, means it should not be repeated. Another, filtered and correlation. All the data which are coming from different monitoring units should gathered, correlate, filtered, and it should be it should not repeated the same incident. So this feature must be in an IoT system. Data enrichment. Enrich raw data stream with contextual information with contextual information and generate composite stream before passing to the next unit. Then the next feature is event store. Query and visualize massive amount of data with integrated business intelligence cloud service, support, and enable big data analysis. So this is one another thing, because it is quite possible that the we are going to attach a huge number of devices to Internet of Things. Definitely, we will get a huge size of data. So we should have a query and visualize massive amount, and to integrate these business intelligence cloud for big data analysis. Enterprise connectivity to dynamically dispatch IoT critical data and event to applications and process flow. The next one is representational state transfer API, REST API. So API based integration with cloud apps and IoT devices must be there. So API based integration and with cloud app and IoT devices should be there. Command and control. So it should send message to devices from enterprise and mobile app independent to device connectivity. I have another figure that will come after 5 to 7 slides, and exactly that figure demonstrated how data collected from the device, how it sends to the server, and then how server will generate the controls for that devices. But in the feature heading, the command and control should be there. Means the server will have the control and can command to the devices attached over there. So the features which I have discussed here, device virtualization, high-speed messaging, endpoint management, stream processing, data enrichment, event store, enterprise connectivity, REST, means API, and command and control. Now, let us come to the architecture. So, so by now you might have understand that IoT is not just an internet connected consumer devices. We therefore need to develop a process flow for a definite framework for which an IoT solution is built. The IoT architecture generally comprises of 4 stages. The stage 1 contains the sensors, actuators, devices, etc. The stage 2 for data acquisition system. Stage 3 is speed processing and edge analytics. And stage 4 is cloud analytics. So in stage 1, a thing in the context of Internet of Things should be equipped with a sensor and actuator, thus giving the ability to emit, accept, and process signal. The first unit will sense the environment, will monitor the environment, generate the data. It may transmit the data, should have the capability to computation, conversion of data, computation of data, and communication of data. So these 3C capability should be there at stage 1, having sensor, actuator, etc. It may accept the signals or controls from other devices which come and process the signal. The stage 2 is data acquisition systems. The data from sensor starts in analogous form, which needs to be aggregated and converted into digital stream for further processing. The data acquisition system performs these data aggregation and conversion functions. So, data aggregation and conversion will be performed in stage 2. The stage 3. Once IoT data has been digitalized in stage 2 and aggregated, it may require further processing before it enters the data center. And this is where edge analytics come. So it is basically a model of data analysis where incoming data stream are analyzed at a non-central point in the system, such as switches, peripheral nodes, connected devices, or sensors. So it is real time, close to business intelligence. So the edge analytics should be performed at stage 3 after digitalizing and aggregation of the data in stage 2. It should be analyzed at stage 3. Then the stage 4 will perform the cloud analytics. The data that need more in-depth processing gets forwarded to physical data centers or cloud-based system. So final processing or computation of data will be performed at stage 4. These are 4 stages, and we may understand these 4 stages in this figure, where the services, security, and ecosystem will be covered in the entire architecture. If I go through this figure, the leftmost side represents the things, primarily analog data sources. It may be devices, machines, people, tools, cars, animals, etc. Then the stages start of IoT, stage 1, 2, 3, 4. The upper line, the top line shows the different services or activities which perform uh, security, ecosystem, and services. So the first stage, which contains sensors, actuators, this may be wired or may be wireless. The stage 2, internet gateways, data acquisition system. This perform data aggregation, analog to digital measurement, and control. The stage 3 is edge IT, which perform analytics and pre-processing. And there is a dotted line which shows the edge. Means the right hand side is part of cloud, and the left hand side is a local modules and things which get participated in IoT system. Stage 4, the data center or cloud, which perform analytics, management, and RPs. Now, the next one shows the different hardwares used in IoT stages. So, sensors, wires, etc. Then switches and monitors, some mobile devices also. Then Wi-Fi, cellular, and satellite hubs are shown over here. Then servers through Wi-Fi, cellular, satellites are there. Then next, you have seen some disk type of things are there, which perform the analytics management control, and it shows the software stack at each stages. So each stages will have different software stacks. The next one, there are two arrows. One is represents the data flow, another represents the control flow. So the direction of data flow, since data will be generated from the things and it will pass through stage 1, 2, 3 up to 4. So it shows the arrow start from stage 1 to stage 4, but actual data is generated at the things state. Once the data will be received at the data center or cloud, it will be replied or responses through a control flow, and the control will come again through all the stages. So all its stages are well connected, having communication channel and bidirectional communication channel. Not only for the stage, the stage 1 also connected with the themes and bidirectional, because to send the data and to receive the control, we should have the bidirectional communication mode. Now the next one is different elements of information, Internet of Things. So the IoT should be capable to interconnecting billions or trillions of heterogeneous objects through the internet. Billions and trillions heterogeneous objects. Because when the number of units will be more and more, uh, we cannot manage the homogeneity of that things or devices. So the six main elements needed to deliver the functionality of the Internet of Things as illustrated below. The IoT is equal to identification, sensing, communication, computation, services, semantics. The addressing methods of IoT objects include IPv6 and IPv4. But many manufacturers or developers prefer only IPv6 due to limitations of IPv6, limitations of addresses in case of IPv6. So identification of the devices, of the things connected to the IoT unit, sensing will perform by the devices connected. Then it will be communicated, the data sensed, data converted analog to digital. Then computation, services, and the last one is UI, user interface, which is shared vocabulary and make it interpretable, because we are using a variety of devices, and it is quite possible that we receive variety of data and need to generate variety of control to that units. So the elements of Internet of Things is again elaborated in this table, where we have shown some samples element wise. So the first element, identification, contains the naming and addressing, and for naming and addressing we have some tools, EPC and Mewport. For addressing we will use IPv4, IPv6, preferably IPv6 will be used. For sensing element, the smart sensors, wearable sensing devices, embedded sensors, actuators, and RFID tags. For communication, the RFID tags will be used, NFC will be used. NFC means near field communication, ultra wideband, Bluetooth, Bluetooth low energy, IEEE 802.15.4, etc. etc. For computation will perform at both the level, hardware and software. So for hardware, we have different choices of smart things, Arduino, Widget, Intel Galileo, etc. Raspberry Pi, our students use Raspberry Pi very frequently. And softwares, Contiki, Tiny OS, and most of the softwares are available open source. So to visualize these elements and to perform, we have, for example, the Raspberry Pi. This is very easily available in the market. The operating systems are, most of the operating systems are open source. So we may start to work for any part of any element And since we are from computer science, we are from electronics, so we will work on any element of these services. Services, identity related, shipping, information aggregation, it is related to smart grid, electricity supply system, collaborative aware, smart home, ubiquitous, and semantics, RDF, OWL, ontology language, and compact XML. So the ultimate game or ultimate goal of all IoT applications is to reach the level of ubiquitous services, and that is why uh, a variety of items for each element is available. So these are four steps in which an IoT system works: collect, transmit, store, analyze, and act. Data is collected through an IoT device, including temperature, pressure, position, motion, and other measures. The data is transmitted via Wi-Fi, cellular, RFID, or Bluetooth technologies. Uh, Sometimes it uses Bluetooth low energy. It is stored. The data is stored. Data is sent to applications running in the cloud or traditional architecture. Then it should be analyzed and performed by software using the rules or algorithms which are already defined for that software within that software. And then instructions are then executed by machine, maybe internet bot, including connections with customers or workforce via app, text, mail, voice message, etc. So IoT has a unique identification that is embedded relying on the RFID connections, which does not need any human or human computer intervention for its work. This is the statement quoted from a paper of Aston in 2009. So the IoT device uses IPv6 addressing for huge data space, which makes it operational, which active monitoring by computers with network connectivity and controlled by sensors attached to that devices. The monitoring and control can be interestingly seen in smart home application where one can turn on the air conditioner while returning from office on the way. So this is one of the application. The detailed application of IoT shows over here means the Internet of Things is related and collaboratively work with wearable technology, smartphones, vehicles, electricity equipments, home appliances, entertainment related activities, your personal computer, laptop, or smartphone. For analysis also, flight services, online shopping. So this is an application, and these all components may be related, may be activated, may get the control from your IoT system. The same thing has been shown over here. The same thing has been written over here. So IoT applications are expected to equip billions of everyday object with connectivity and intelligence. It is already being developed extensively in various domains, and we see some advertisement in our TV that and any actor controls its AC from anywhere else using mobile phone. So the other applications which are in use or maybe in use in more effective manner, and these applications are agriculture, pollution control, industrial automation, and disaster management. since I'm looking Unnat Bharat Abhiyan program also, and I seen that many of the companies are working on smart agriculture system, and even Bhabha Atomic Research Center has created many tools based on IoT or based on communication system, based on sensor system for a smart agriculture. So wearable technology is a hallmark for IoT application and probably is one of the earliest industry to have developed the IoT at its service. We happen to see Fitbits, heart rate monitor, and smart watches everywhere these days. So this is a good thing. And this is one small application of the IoT. The smart home is another application which you have seen that there are many equipments and appliances in your home, and these may be controlled. These can be monitored and using internet and your phone via your phone. So when we talk about IoT applications, smartphone are probably the first thing what we think. The best example I can think of there is Jarvis, the AI home automation employed by Mark Zuckerberg. Healthcare, again, IoT application can turn reactive medical based system into proactive wellness based system. Even though the patient is on the move, this vital can be continuously sent to the doctor with the help of IoT platform. IoT opens way to see a valuable data through analysis, real-time field data, and testing. IoT also improves the current devices in power, precision, and availability. IoT focuses on creating systems rather than just equipped. Smart city, this is an example of Palo Alto, where the parking slots are embedded by sensors, and these sensors will generate the signal to the central system via cloud, and that message will get to the drivers of the cars, which know in advance that which slot is free. So the things about the smart city concept is that it's very specific to a city. The problem faced in Mumbai are very different than those in Delhi. So, but this is not the exact example of smart city. Whenever, since I already told you, whenever I we talk about the smart city, the entire city should be smart. If a person is working in his office, he got some message, emergency message from his home, either to uh, either related to medical issue of any family member or any accident in his home. Simultaneously, the concerned unit of the city should be alerted through same message. It is not related. So this is just an example of smart parking, not entire smart city. Agriculture. The sensor should be deployed to monitor the light, humidity, temperature, and using AI on the data received from the sense data, the it should generate the signal for irrigation, signal for pesticide, or any other activity. And that type of uh, system already generated by many industries. Even Bhabha Atomic Research Center has worked a lot for smart irrigation system, because this is a very big challenge to feed a such massive population uh, which need to uh, marry agriculture to technology and obtain best result. We do not have any substitute of food. So and we have to do a lot of effort to improve the quality and quantity of production of the foods. This is the greenhouse example, the smart greenhouse having different equipments for to maintain the temperature, humidity, etc., etc. All the equipments will be connected uh, to a remote control system via gateway and having a monitoring system, having a also a remote control system for a smartphone, and accordingly it will change the status of different uh, equipments equipped in a smart greenhouse. A smart grid. With a smart grid gateway, distribution can be optimized because uh, we do not have option to store the generated electricity. So these grids also keep collecting real-time data which helps in distribution electricity efficiently and also to reduce the outages. Not only reduce the outages, control the outages. At what time we require more production, at what time we need to reduce the production. That type of decision must be taken in case of grading system, and in case of smart grading system, these all decision has been taken by the automated or IoT based system. Pollution control. This is again a very great challenge for us. So where CO2 level has been increased, where noise pollution and water pollution has been increased. Accordingly, the administration should take the decision, redirect the vehicles, stop the noise pollution. Or so the IoT platform helps us to continuously monitor the air pollution and water quality. This data will be sent to the cloud where further analytics can be performed so that a proper action can be taken to control pollution. Again, an industrial automation where we can uh, do the factory digitalization, logistics and supply chain optimization, packaging optimization, product flow monitoring, inventory management. All should be connected and get automated control from the central unit. Quality control, safety and security. This again is very important thing, that is national disaster management. If it is based on IoT, definitely we will save more lives and reduce the losses during the natural disaster. So the Internet of Things platform can be used to accumulate data related to a specific geographical location using a remote monitoring tool and perform analytics so that early warning of disaster can be found. In last 4 to 5 years, we have seen many disasters in our country, and it is a good that we get alerted sometime before, be cautious, and the losses get much reduced than whatever losses we faced 10 years before. Now, the protocols, different protocols which are available for IoT system, we need to discuss it because without protocol, we cannot execute any communication system. So, so there are many protocols that have been that have a direct or indirect role in IoT. We are focused on two protocol types in the particular. First one is network protocol and is data protocol. The network protocols we use for IoT should be open standards because our IoT network has to support devices from multiple vendors. It's not it is not authorized to any one vendor. Any vendor can, because we are going to use millions and trillions of devices, and that all devices should be connected. So we should have an open standard protocol. Proprietary protocols increase complexity because you then need devices that can be translated between the different protocols. This may be possible that if different proprietary protocols which we use, but there should be an intermediate system or protocol for conversing the syntax or whatever will be required. The Internet protocol is well established and we have been using IP for IT networks for a long time. This is one of the reasons why IP is also the main choice for IoT networks. We will still stay on IP Internet Protocol system. Using IPv6 is encouraged because there are no address space limitation as there are with IPv4. That is why we encourage us to use IPv6. Solutions such as IPv6 over low power wireless personal area networks 6LO WPAN, WPAN or IPv6 routing protocol for LLNs don't even support IPv4, only IPv6. So the protocols IPv6, LLN or RPL, it doesn't support IPv4. So IPv6 can support only IPv6. Data protocols. So we have three type of data protocols over here. First one is message queuing temperature transport MQTT, constrained application protocol, and extensively message and presence protocol XMPP. MQTT is probably the most used protocol in IoT. It's a lightweight message protocol that uses publish and subscribe operation to transmit data between the client and server. It
Sir,
uses this. Huh.
sir, sorry to disturb you, sir, but we have little time foundation, so it will not appropriate to interrupt you, sir. But other speakers are also it's time at 12.
Okay, so should I conclude now?
I think, sir, we should take a questions and answers here, or we can I
Okay.
can share your presentation with the participants here later on with
Yes,
other
yes,
speakers.
I will send my presentation to you, and
Yes, sir.
because I
Excuse
think
me, sir.
And later on,
Excuse
if
me,
we have
sir.
any query, you can discuss with the sirs here. Okay. Huh. If you have any query, then you can ask to the sir.
Can you
Please.
please complete this particular protocol stack in IoT? This part only.
MQTT.
Yes, sir.
Okay, so I think it is visible. Basically, it works on client server concept, but the words has been changed. It is published and subscribed. So a device or client, I have analog with the client server model. Here the clients are the devices which are connected and send the data. So the publish, they will, whenever they send the data, it uses publish word, and the server which are at the central system which get the data through clouds will act as a named as a broker, but if I make the analogy, it is a server. So it uses publish to send the data, data will be published, and subscribe means when it gets the control from broker or server. Tripathi ji? So I think I have my time has been finished now. So I am stopping myself over here, and I will share the PPT to Dr. Sri Vishal Tripathi. If it will be required, we will share with you. Thank you, Tripathi.